So for the next page, we have day 2 of the materials. Now, if you look at the top 2 questions, you are presented with an equation for each. So let's take a look, okay? Let's take a look. Let's take a look right here. If you just stare at this equation, what kind of information you can tell? For sure. Y-intercept, no, actually. No. Yeah, I mean, you could, but the y-intercept is not h, by the way, because that's not exactly the, the standard form. What can you tell? You can, in fact, put something easier. What can you tell? I would say it might be positive, but something even more obvious. It opens what? Again, we're not sure, but we know one thing that is. It must be vertical, because the x is squared. Okay, we know it's vertical, but is it opening up, opening down? We will find out. We don't know yet. Now, if you look at the equation that we just wrote earlier, okay, now right here and right here, what you realize is that the standard form of the parabola, it's always going to have a perfect square on the left, and then everything else on the right. And if you have the standard form, you can get quite a few pieces of information. You can actually get the graph drawn if you have the equation. But what's the dilemma right here is that if you look at this equation, the only thing you can extract is that, oh yeah, it's a vertical parabola. Other than that, we don't know. So that becomes our job to extract more information. So we're like, yeah, it's going to be a vertical parabola. So we're going to keep x squared minus 4x on the left, because we are going to create a perfect square since x is squared. And everything else, we will send them to the right-hand side by adding 4y and subtracting 8 on both sides. Okay, now, again, make sure that you are asking yourself, why? Why are you doing this? What's the benefit of doing such a move? Because now we can make an attempt to create this perfect square. But as of now, we don't have all the ingredients for this perfect square. We are missing one final ingredient. Do you know what the final ingredient is to make this perfect square, also called completing the square? What do we have to add over here? Not 16? 4. Because you divide this 4 by 2, right? Which is 2, and then you square it. So you got to add 4 on both sides, so that your perfect square, it's going to be x minus 2. Okay, x minus 2 parentheses square, it's x squared minus 4x plus 4. So that's why you can replace them. On the right-hand side, you have 4y minus 4, and you factor it out. And now, look at what you've got. You've got a standard form, and now if I ask you, can you tell the vertex now? And you would say, the vertex is 2, 1. So I want you to see the contrast. And the contrast is that at the very beginning, that equation, it's barely helpful. All we could tell is some sort of vertical parabola, and that's all. Okay? That's all I could tell, all we could tell. And then we're like, can we get more information? And we're like, sure, if you want to get more info, do something about it. And then we say, all right, let's go ahead, change it to the standard form. And now we can tell the vertex, and in addition to the vertex, we also know that 4p is equal to 4. That means we have a vertical parabola that's opening up. And then we can also tell that P is equal to 1. So now, if that's the case, with all the information given to you, can you go ahead and draw the parabola with the given vertex and the p-value? Can you go ahead and draw the dots so that we can have a nice picture of the parabola? So if you draw the vertex will be right here. And we know it's going to be a parabola that's opening up. So we know the focus will be just 1 unit above. And then the endpoints of the lattice rectangle will be 2p units, which in this case will be 2 units on the 2 sides of the focus. So there we go. Okay, we also need to draw our directrix. So the directrix will be right here, 1 unit away from the parabola or from the vertex, downward. Okay, so you have your picture. Okay, you have your vertex, you have a p-value. You will get the job done. And now with this picture, you can now go ahead and, well, write down, fill in the blanks right here. Now let's go ahead and write down the standard form. The standard form is the one that I provided you, or we obtained earlier from completing the square. Okay. Now about the vertex form. So let's make sure that we are all understanding vertex form. And if you have a highlighter, this would be a good time to use a highlighter. When we deal with the vertex form, it's always the variable that's not being squared, that's being set equal to. So x is squared, right? So we'll solve for y, basically. If you want to solve for y, you need to get rid of 2 things. You need to get rid of the 4 and the -1. How do we get rid of the 4? Divided by 4, right? So you would divide it by 4. So next to x minus 2 squared, you have a 1/4. So we got the 4 away. And then how do you get rid of the -1? +1. So that becomes your vertex form. Okay. Again, you send the 4 over by dividing. And then at the end, you just add 1 to get rid of the -1. And voila, you get your vertex form. And you can now really fill out all the numbers, all the blanks down below. So it opens up. The p-value, the absolute p-value, it's 1. The a value, it's right here, by the way. Now, we don't really use it a lot here, but you will use it a lot more in the next course in pre-calc. So a is practically 1/4p, okay? So that's why when p is 1, a is equal to 1/4. The vertex is 2, 1 from the graph. The focus is 2, 2 from the graph. The rectrix is y equal to 0, again from the graph. And axis of symmetry is x equals to 2, also from the graph. Okay? Also from the graph. We're good? Okay.